In the next unit, we'll be looking at writing chemical equations and different types of chemical reactions. So first, we're going to just review what we know about balancing chemical equations, because that's essential to writing full chemical equations. When you're writing a chemical equation, whatever you're putting into the reaction are your reactants. So it's the things you're starting with. Reactants react to make products. So products are the things that are formed during the reaction or produced during the reaction. So a chemical equation has the reactants on the left-hand side. Reactants react to produce the products. So reactants on the left and products on the right. Products are being formed. If there's an arrow pointing only in the one direction, only toward the right, it indicates that the reaction only goes one way. So if the reactants only can form the products and it can't be reversed, then you have an arrow going only to the right. We never draw arrows just to the left. That's like going back in time. So an arrow to the right means the reaction can only go one way. If it can be reversed, so if you could have hydrogen gas and oxygen gas react to make water, the arrow going this way would be hydrogen gas and oxygen gas make water. But if you put electricity through water, you can make the hydrogen gas and the oxygen gas come back out. So it is reversible, would be an arrow going both directions. You put a delta sign or the triangle sign above the reaction arrow to indicate that heat was applied to get the reaction going. So heat's going in, you put a delta or a triangle sign above the arrow to show that there was heat going into the equation. So that would be endothermic. So here's a word equation. Iron and oxygen will react naturally on their own. And when they do so, they make rust, which is iron 3 oxide. In a word equation, the reactants and the products are identified by their names only. So iron and oxygen are the reactants, and iron 3 oxide is the product. So one product is being made in this one. That's a word equation. It's written in words. Okay, so we wrote out iron, I-R-O-N, so on and so forth. We then turn word equations into skeleton equations, or sometimes called symbol equations. This is where we just use nomenclature skills. We turn the words into formulas. In a skeleton equation, the reactants and products are identified by their chemical formulas, including the state of matter. This is going to be new to us in Chemistry 11, but we don't include any amounts yet. We just turn the names into the formula. So iron became Fe, and it's a solid. Oxygen gas is part of Broncliffe or Hofbrinkel. It becomes O2, it's a gas. It will react to make iron 2 oxide. That's Fe2O3, doing swap and drop with charges. Rust, iron 3 oxide is a solid. So that's the S indicates the state of matter. S is solid, G is gas, L is liquid, and then AQ is aqueous, and we will be adding that to our acids, showing that they've been dissolved. So remember, all of your normal diatomic atoms, Hofbrinkel, Broncliffe, include the number 2, subscript 2 with them. Before beginning to balance a chemical equation, always to make sure you've written it correctly. If you have improper nomenclature, you can sometimes make an equation that's not balanceable and it's not right from the beginning. Please, please, please double check your nomenclature. That's why we start with that and we emphasize it so much. And you never change a compound formula during balancing an equation. So we don't change subscripts. We only ever add coefficients for big numbers in front. Never ever the subscripts. Those come from either the molecular prefixes in the name or swap and drop with the ionic charges. Don't mess with the subscripts. So here's an example. Magnesium metal burns in oxygen gas to make it produces a bright white light, and it makes a powder called magnesium oxide. The word equation would be magnesium plus oxygen gas, arrow, magnesium oxide. Then the symbol or the skeleton equation, magnesium is Mg, it's a solid. Oxygen gas is O2 because it's diatomic, part of Hofbrinkel. It's a gas. It makes magnesium oxide, +2 -2, MgO, and it is a solid. It says it's a white powder substance. This would be the symbol or skeleton equation. Now it's not balanced. If you look at the left-hand, right-hand side, the reactants, the products, the left side shows 1 magnesium. The right side shows 1 magnesium. Perfect. On the left is oxygen gas, which has 2, and on the right side, magnesium oxide only has 1. So it looks like we've broken the law of conservation of mass, or we've broken John Dalton's atomic theory here. Looks like we destroyed an oxygen. That can't happen. So instead, what we do is we put big numbers in front to show that we've balanced it. If I put a 2 in front, this is just like in math with distribution, it distributes the 2 into the magnesium and oxygen. So now I have 2 magnesium and 2 oxygen. So the oxygen is balanced, but now I have a problem because now I have 2 magnesium. So we keep going with this left-hand, right-hand check. I put a 2 in front of the magnesium and now it's balanced. 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen, and now it's balanced. Silverware reacts with the solid sulfur to become tarnished, producing silver sulfide. So here's our equation. It's silver reacting with sulfur to make silver sulfide. Silver is just Ag, it's a solid. Sulfur, it says, is a solid in the word equation. So this is just S. It's not part of Brooncliffe or Hofbrinkel. So it's just S, and it says it's a solid. Silver is +1, sulfide is -2. Swap and drop gives me Ag2S, and it is a solid. It's not balanced though. It looks like I've created a silver in this process. You can't create or destroy atoms. The mass of the reactants has to equal the mass of the product. So something is not right here. So we add numbers in front. I'm going to add a 2 in front of the silver. 2 silver as a reactant, 2 silver as a product, 1 sulfur as a reactant, 1 sulfur as a product, and it's now balanced. Aluminum metal reacts with hydrogen chloride gas to create solid aluminum chloride and hydrogen gas. Word equation would be aluminum plus hydrogen chloride, arrow, aluminum chloride plus hydrogen gas. Nomenclature then. Aluminum is just Al, it's a solid. Hydrogen chloride says it's a gas, so +1 -1. It's just HCl. Makes aluminum chloride +3 -1, so AlCl3. It says it's a solid and hydrogen gas. You can see there's a couple of things imbalanced here. The aluminum is fine, 1 and 1, but there's 1 hydrogen on the left and 2 on the right. There's 1 chlorine on the left and 3 on the right. So I definitely have a problem here. A couple of tips and tricks. If you notice an odd and an even number on the right hand, on the left hand, right hand check that you're doing, for example, 1 hydrogen, 2 hydrogen, make the odd one even. Usually try to double it. That might cause some of the issues that we might be having to resolve itself. If I added a 2 in front of the HCl, that only makes 2 chlorine. So that's not going to work. A 4 isn't going to work. I don't have 4 Cl, but I could try a 6, an even numbered 6 in front of the HCl. If I put a 6 there in front of the HCl, then I can add a 3 in front of the hydrogen gas on the product side, and I could put a 2 in front of the aluminum chloride. So you may have some back and back checking. The 3 doesn't work. So instead, we got to figure out what can work. So I know I need to come up with an even number of hydrogens because I have 2 on the product side. So instead, we try a 6. 6 hydrogen can be balanced. I just need a 3 in front of my hydrogen gas in order to balance the 6. I would need a 2 in front of my aluminum chloride because I had 6 chlorine on the reactant side. So I double the Cl3 to make 6. That makes now 2 aluminum, and then I have to put a 2 in front of the aluminum. So sometimes you're going back and forth, trying different coefficients in front, seeing if you can make them balanced on both sides. Always check to see if you've accidentally doubled everything, see if you can reduce it. A 2, a 6, a 2, and a 3 cannot be reduced. So you know that you have put it in simplest form. Iron reacts with oxygen in the air to form rust, which is iron 3 oxide. We looked at this. Iron is Fe, it's a solid. Oxygen gas is O2 gas, and iron 3 oxide is Fe2O3 with swap and drop. So my problems here, I have 2 iron on the product side and 3 oxygen. So it looks like I made an iron and an oxygen. So again, we're just working with our coefficients. If I put a 2 in front of the iron on the left, I can't balance the oxygen. I have 3 on the product side and 2 on the reactant side. Those can't be balanced. So it can't be a 2 in front of the iron. So what we're going to do is make the odd side even. Double the iron 3 oxide, put a 2 in front. That now gives me 4 iron, and it gives me 6 oxygen, which I can balance. So if you have an odd and an even number, make the odd side even, usually double it. If that doesn't work, then try 4 or 6. Try even numbers in front, see if you can get it to work out. So 4 iron, 6 oxygen, and now it's balanced. Sodium metal reacts with water to form an aqueous solution of sodium hydroxide and hydrogen gas. So sodium metal is just Na, solid. Water, obviously H2O is a liquid. Aqueous, what's been dissolved, sodium hydroxide is NaOH plus minus 1. And hydrogen gas is part of Roncoulomb-Hofbrinkel. So this one's a little bit tricky doing the left and right hand check. I see one sodium, fine. 2 hydrogen, but on the product side, there's actually 3 hydrogen. 1 with dihydroxide and 1 with the hydrogen gas. So I have 3 hydrogen. So I've made 1 somehow, broken the law. 1 oxygen is fine. Because I have an odd number on the product side, make the odd one even. So if I double the sodium hydroxide, I now have 4 hydrogen on the product side. That I can easily balance. I just got to put a 2 in front of the water. On the product side, I have 2 sodiums, put 2 in front of the sodium, and the oxygen balances out 2 and 2. So that one is balanced. Silver nitrate reacts with aqueous calcium chloride to form solid silver chloride and calcium nitrate. This is why nomenclature is so important. Silver nitrate is +1 -1, so AgNO3. It's aqueous, it's been dissolved, so include that with the state of matter. Calcium chloride is +2 -1, so CaCl2. Silver chloride is +1 -1, so AgCl. And calcium chloride is +2 -1, so swap and drop. Nomenclature is so important. So you can see that I have somehow destroyed a chlorine in this process, and I've created a nitrate. Can't happen. So the coefficients will help us. I throw a 2 in front of the silver nitrate to get 2 nitrate on that side. That now creates 2 silver. So put 2 in front of the silver chloride. Oh, and it's balanced because that now gives me 2 chlorine on the product side, and I already had 2 on the reactant side. 1 calcium is fine. Stop and do the left hand, right hand check. A lot like you're in algebra and math class again. Make sure both sides are balanced. Aqueous potassium chlorate, when heated, makes potassium chloride and oxygen gas. So potassium chlorate is +1 -1. It's aqueous. When it's heated, it becomes potassium chloride, which is KCl +1 -1, and oxygen gas. It says it's heated, so I have to add my little triangle, my delta sign in, above the arrow. So heat is going into this to make it happen. It's not balanced because I've somehow destroyed an oxygen. Notice my odd and even number. Odd side of oxygen on the reactant side and an even number on the product side. So that may double the odd one. So I'm putting a 2 in front. That gives me 6 oxygen. I can work with that because I can put a 3 in front of my oxygen gas. I would also need a 2 in front of my potassium chloride. And now it's balanced. So 2 potassium, 2 potassium, 2 chlorides, 2 chlorides, 6 oxygen and 6 oxygen. Balanced. So what I'm going to have you guys do is answer these 5 questions, and I'll have you upload that to Edsby. Also, I'm going to have you complete some levels on a chemical balance online simulator, which I will put the link to as well. When you guys complete the different levels, if you're in class, show them to me and I'll record them. Or if you're not in class, take a screenshot and please send those to me as an Eds message when you completed the different levels. If you have questions with any of this balancing, please don't hesitate to ask, because as I've been mentioning, chemistry builds, and we will be working now with whole equations, nomenclature and balancing.